Something like this, and this is what they give us. And it says find u and v. I'm on page 2. Chepe, you're on page 3. Okay, well, here we are, and they want us to find u and v. So here's what I'm noticing right away. If somebody said to me, think about this, folks, if somebody said to me, in this triangle, what is the cosine of 60 degrees? If somebody said that, I would write this. I would say, well, cosine of 60 degrees is equal to, well, adjacent over hypotenuse. Cosine 60 degrees, adjacent over hypotenuse. And I would say, well, the adjacent side is 2. And the hypotenuse is u. So I would say cosine of 60 is 2 over u. And then I would say, well, this has to equal 1/2. Because the cosine of 60 degrees is always 1/2. Doesn't matter how big the triangle is or how small. Cosine of 60 degrees is always 1/2. So I'm just going to come here and say, okay, this needs to equal 1/2. Let's solve for u. Try to solve for u on your own, but let me take a question of how I got this, if there's anybody here. Carla?
So we have to memorize all the cosine and sine for the natural right triangle?
Well, certainly, we will get to that point right when we know of unit circle. We have to memorize all that. But I don't think it's memorizing. I think it's memorizing these, and then knowing this, and then being able to get this. It will become memorized after you do 100 problems. But for right now, you don't need to worry about memorizing. You just need to worry about, let me know these, and then let me know this, and then I can get these. Does that make sense, Carl?
Mm-hmm.
So you good? Does that answer your question?
So using one.
Yeah. Mm-hmm. Use 4. So 2 times 2 equals u times 1. 4 equals u. So I would do this. You don't have to do this. What I would do is I would redraw the triangle with a 4 written here. Again, you don't have to do this. I would do it though. And now I need to find v. There are 3 ways to find v. Anybody have an idea how I could find v? There are 3 ways I can see. Marvin, you have one?
2 squared plus b squared equals 4 squared.
Certainly Pythagorean theorem, which says a squared plus b squared equals c squared. So let's see how that would work. Well, a is 2, so 2 squared is 4, plus b squared, I don't know what b is, equals 16. So b squared must equal 12. So if b squared equals 12, b must be the square root of 12. And I'm not going to put the minus because this is a length of a side. It can't be negative. Has to be a positive number. So we'll say b equals the square root of 12. And you guys learned with Mr. Kurth, I guess you can rely on Mr. Kurth some more here, that this can be simplified a little bit to maybe 2 root 3. Because you have a 4 inside, it's inside is 4 times 3, the 2 comes outside, the root 3 stays in. So that's one way to do it. There's some other ways. Anybody see another way to do this? Assume we don't have the calculator. Rafa? Okay, so Rafa said let's do the cosine of 30. And then what would you say, Rafa? That equals what in this problem? V over 4. Adjacent over hypotenuse. And that always equals, let's find out, root 3 over 2. Okay. Root 3 over 2. And now this is solved just like that. So let's do cross multiply here. 2v equals 4 root 3. Divide by 2, divide by 2. V equals 2 root 3. That's another way. There's a third way. Does anybody see a third way? David?
I have a question. When you looked at it as square root of 12 over 2.4.
Yeah, you would get about a point off. Yeah. Which is why, so over here in this way, we don't need to worry about that because like we don't have to. So the other way, right, would be I could say, well, what is the sine of 60 degrees? Sine of 60, opposite over hypotenuse. V over 4, and that equals root 3 over 2. And now we're at the same spot as we are here. Carla.
V did 2V over 2.
So I did a cross multiplying here, so that 2v equals 4 root 3, and I divided both sides by 4, not 2. Good job. So there are multiple ways, Aldo. I know, I did divide by 2, yeah. Why? Because I doubted myself. You divide both sides by 2, yeah, because you want to get v by itself, yes. Does that make sense, Carl? Good. So, 2 ways of solving the same, really 3 ways of solving the same problem. Okay, let's do another one. Let's do the problem on page 3 about Mr. Newcomer with his plane. Page 3.
I just get things.
All right. So here we go. Carla? Two triangles, what do you mean by 2 triangles? Oh, so I drew the second triangle because one side solved for one side. I just wanted to redraw it where I had labeled that side. That was all I did. All right, guys, I hear a little bit too much discussion. So if it's not about pre-cal, then so here we are. This is 2,400 feet off the ground. This is the field here. There's a dashed arrow here. And they tell me this is 30 degrees. They tell me this is a right angle. So here's the important realization right here. This right here
60.
needs to be 60 degrees. Because these 2 lines right here for the plane and the ground are perpendicular. His plane is going like this, the ground is coming like this. This is a right angle here. Someone.
Are we just about the same that is
Yes. And we also know there's a geometric theorem that says these 2 lines are parallel. So these are alternate interior angles. You might remember this with a transversal. If you have 2 parallel lines and you cut it here, this angle will be the same as this angle. We have this kind of thing going on. Here's a parallel line. Here's a parallel line. So if we draw the z, this will be equal to this. This will be equal to this. I mean, so that's the formal proof, but basically you could just assume that because he's going like this and this is the ground, 90 degrees. Yeah, exactly. There's a lot of different proofs here. Exactly. That's right. So what do they want us to find? They want us to solve for the horizontal distance to the field. So they want us to get this. Horizontal is side to side. So they want us to say, how far is he now from the field just horizontally? I don't care about the vertical part, just this way. Well, let's see what we can do. Luis?
Is there the same thing as in the bottom?
Yes, exactly. It is the same as this. Very good. It is. So I need to find this. That's right. These are the same. You can call it x. X. How am I going to find it, though? David, what do you think?
When you multiply by 2, because just trying to find the hypotenuse, and you have the.
Hold on. So I have this, and I want this, but you're saying you want to get this first, then you'll get this?
Yeah.
Okay, I think it's a good idea. So how are you going to get this? Let's try to use one of the ratios. sine or cosine of an angle? Let's try that. You can do it, David.
So
So you want this, let's call it h for hypotenuse. You want h, and what do you know? You know this side. How could I do that? How could I relate that? What do you think, David? So if I do cosine of 60 degrees, in terms of this triangle, what is that going to equal?
So that's 200, 2400.
2400 adjacent over
Um,
h. And that has to equal 1/2. Has to equal 1/2.
4800.
So therefore we've already found h. 4800. Cross multiply. H equals 4800. So call this 4800. Humberto.
Is it possible to like multiply like vertically? Like say like 1 times 2 equals 2 and then 2,400 times 2 gives you.
Will that always work? I'm not sure if that'll always work. Maybe it's just work because there's 1/2. I'm not sure.
So the logic that I was using, that I was telling you firstly about is that, so you have that side, so you multiply it by 2.
Right, okay, yes, because of the ratio. Yes. But we want to build this skill because for the unit circle, knowing this is going to be super crucial. But you're right. Miguel.
You can't use tangent.
We can, but we haven't taught tangent yet, so my expectation is people don't know that. But if you know what the tangent of 60 degrees is off the top of your head, because remember, this will be without a calculator.
Oh. Oh. Oh.
This is without a calculator, folks. Luis,
So for this unit, are we gonna learn about the wheel?
we're about to, in about 3 minutes. We're about to get there. So the hypotenuse is 4800. So now I can find this, your choice, Pythagorean theorem, or another trig ratio. Pythagorean theorem is really hard here with very huge numbers without a calculator. I would encourage people to use another trig ratio. How could I use trig to find x now? How could I use trig to find x, Luis?
Oh, I'm sorry.
I'll assume that I was like speaking Greek and you don't know Greek.
Sine.
Sine of what?
Sine of 30.
Sine of 30, but the problem is that's going to have this side.
No, wait. Of 60.
Okay, good. So a lot of conversations going on outside, they're not about pre-cal. So either you are doing the problem on the board or you're doing something else. You have many problems to do. Nobody is sitting idle talking about something else. Sine of 60 degrees, opposite over hypotenuse, so x over 4800 equals root 3 over 2. Cross multiply and you're done. 2x equals 4800 root 3. Divide both sides by 2, and here's our answer. X equals 2400, bless you, root 3. 2400 root 3. Oh, sorry.
I thought like on X and 2400 could be like the same size. Because it's 3600.
But they're not the same size. This is a 2400, 2400 root 3.
Oh,
All right, and now in part B they say, assume that we keep driving the plane, we keep flying the plane until the horizontal distance, this horizontal distance, is equal to the vertical distance. Well, this distance is how much? 2400. So I keep flying until this distance is 2,400, and then it says how far are we from the field? The total distance. Well, this is a right angle. If these sides are equal, I want to find this. I'll call it D for distance. I want to find D. What do I know about these angles? Even once I call it. What do I know about these angles? What do they have to equal, Abarca?
45, 45, 90.
45, 45, 90. Because this is an isosceles, sides are equal, right triangle. Isosceles right triangle, 45, 45, 90. And now I use the trig ratios and I'm off to the races. Or Pythagorean theorem, but without a calculator, trig's easier. Carlo.
I don't understand why you use participles.
Because it says he keeps flying. Right, if you read the prompt, it says he keeps flying until this horizontal distance equals this. Right now the horizontal is a little bit too big. So I need to keep flying to make this smaller so it equals this.
Why didn't it just be 2,400?
Because it says he keeps flying until this is equal to this. Here, can you read the problem aloud? Too much talking over here on the left.
Mr. Newcomer continues to fly his altitude until his horizontal distance from the equator is equal to the altitude.
Right, okay, so hold on. So until the horizontal distance from the field equals the altitude. So the altitude is 2,400. So we need to make this horizontal part equal 2,400.
And how do you know where to start?
Oh, I mean, who knows? I could pick somewhere anywhere here. That's not necessarily crucial. I mean, it doesn't have to be drawn to scale. I'm just drawing a new triangle like this, where this is 2,400 and this is 2,400. I'm going to solve for this.
How do you know it's 2,400?
Because the altitude is 2,400.
Oh, the long line.
So they want this to be equal to this. Brenda, you had a question.
Oh, yeah.
So now you want to use trig ratios. So I want to say, well, the sine of 45 degrees, sine of 45 equals opposite over hypotenuse, so equals 2,400 over d, and that needs to equal root 2 over 2. Solve for d. I won't belabor the point because we're a little bit short on time, and everybody knows how to solve this. I've done 3 examples like this. Cross multiply, isolate d, make sure there's no radical in the denominator, blah. All right, here we go. We are moving on. We are moving on. So you're just going to solve this out. You don't need to do it right now. You don't need to do it right now. This is the setup. Everybody can solve. Just cross multiply. That's it. Just like I've been doing. All right, here we go. So, unit circle. By the way, too few people watch the videos on Khan. I'm upset about this. You had a 3.5-day weekend and you can't watch 3 videos or 4 videos? That's embarrassing. Everybody should introspect. That means look inside and think whether you had 30 minutes this weekend to watch 3.5 videos. 3 videos. Over a 3.5-day weekend. While I was grading for 10 hours yesterday. Come on, folks. We got to pick it up. We got to pick it up. This is the hardest part. If you don't understand this, you are game over for the semester. Literally, you'll either be back with me next year or you'll be in HCC. I'll tell you right now. If you don't understand what I'm about to do, you are done for the semester. Can I say it with any more emphasis? No. This is the game right here. Yeah. I can. Or you can always pause me online. All right, here we go. Unit circle. So imagine a circle of radius 1. Imagine a circle of radius 1. You're going to want to draw it nice and big.
an oval.
If you're going to belabor that point, you're going to be in deep trouble. Draw a circle of radius 1, centered at the origin 0, 0. So we have a radius equal to 1. So that means that the distance, we all know what a radius means, right? The distance from the center of the circle to any point must be 1. So this distance from here to here must be 1. This distance from here to here must be 1. This distance from here to here must be 1. And this distance must also be 1.
Diameter.
The diameter is 2. Now, this coordinate must be 1, 0. This must be 0, 1. This must be negative 1, 0. And this must be 0, negative 1. Radius of 1, right? All right. So, any questions on this one so far? So let's assume for discussion purposes you draw a line here. We know the distance of this line is 1. The distance from the center to any point on the circle is 1. This right here is 30 degrees. So I drew a 30-degree angle. And I'm going to say, well, let me draw this downstairs. This becomes a right angle. So now I have a triangle. Here, here, here. This angle must be 60. So I have a 30, 60, 90 triangle. I hope, and this is the big leap, and if you can make this leap, you're totally good, that you see that this is just this turned on the side. That is all we've done. I've just drawn this triangle like that. All we did is we took this and we said, let's draw it like this. That's all we did. So, what does this length have to be right here?
1/2.
1/2. So that means this y coordinate, if this is 1/2, the y coordinate must be 1/2 here because I go up 1/2 units. And then how much is this distance here? So this x coordinate must be root 3 over 2. Questions? And since we talked about radians also, let me just put this in radians. This is pi over 6. We all know how to convert that using the railroad tracks that we did on Friday. But in radians is a pi over 6. Not right now.
No, I mean.
In the future, yeah.
Can you re-explain the logic?
Yeah, I can re-explain logic. So this triangle is just this one drawn like this. Does that work, dude? So this 1 right here is just 1 here. So this is this. This is here. So this small side is really this. So I just kind of turned it on its side. So that means this is going to be 1/2. So this will be 1/2. This is going to be root 3 over 2. So then this will be root 3 over 2. And for this coordinate right here, what is the x distance from here to here? So that's how it's root 3 over 2. And the y distance is how much did I go up? I go up by 1/2. Let's draw the next angle. Brendan?
Where do you get pi over 6?
Pi over 6 is this angle in radians. So we talked on Friday, we said if you have 30 degrees, you can draw the railroad tracks, 180 degrees, pi radians. Right? This is a 30 pi over 180, 3 pi over 18, pi over 6. So I won't go through how to do that for every single one, because I kind of already know them, and you will too soon, but that's how you would do it. So, the next angle is, call this angle 45 degrees. This whole angle. So from here to the bottom, call it 45. I'm just going to write it in here because I have a little more space. But we know it goes the whole way. 45 degrees. And in radians, that'll be pi over 4. And again, I would go through that process if you want to prove it to yourself. And let's draw the line down. So this is 1, because this is, again, the radius. So now this triangle is just this one on its side. We drew this down, so here's 90. There's 45. This is also 45. So if this is 45 and this is 45, then that means this length here must be root 2 over 2. Because in a triangle of radius or of hypotenuse 1, the sides are root 2 over 2 and root 2 over 2. So this distance is root 2 over 2, and this distance is root 2 over 2. So I'll go ahead and label my point. And now we just have one more point. Call this angle 60 degrees, also known as pi over 3 radians. Jenny. Is that helpful? Yeah. So now we're on this like maroon. Yeah, Miguel.
So the point is doing all this to find the points.
Yes.
On the side.
Yes.
So we want to find out every point that's on that circle.
Not every, because they're infinite. Only the important ones that have 30, 60, 90 angle, or 45. That's it. And in the future, by I would hope Friday, probably more realistically Monday, you will not draw this every time. You'll just have it memorized.
Can you read the radian for the 45, 45?
Pi over 4. Yes, exactly. Exactly. Yes, 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 yes. So if you know the triangles, this is super easy. You just have to rotate the exact. Yes, exactly. That's why I did the triangles first. Exactly.
Why can't we just memorize the triangles?
Huh?
Why can't we just memorize that?
I mean, hopefully you guys did. That's why you're studying your notes all day. All right, here we go. So 60 degrees. So this big distance for 60 degrees, the big distance is root 3 over 2. So that means that the y coordinate is root 3 over 2. And this small little x distance must be 1/2. Must be 1/2. And the last angle is, this whole angle right here is 90 degrees, also known as pi over 2. And here comes the genius of the model, right here. This is why it's so helpful.
Reflection.
This is why it's so helpful. The x-coordinate is the cosine of the angle. So if you want to know what the cosine of 30, root 3 over 2. If you want to know the cosine of the 45 degrees, root 2 over 2. If you want to know the cosine of 60 degrees, 1/2. And the y coordinates are the sine values. That's the genius of it. The x coordinates, the x coordinates are cosine of theta, and the y coordinate is sine of theta. Jump in. Don't worry about tangent yet. Next week.
same thing as just converting, not from degree to unit.
Yeah, that's how you get the radians. Yeah, exactly. Miguel.
So, would they ever like give us the points and then tell us to draw a circle?
I mean, on Friday, we're going to say, here's a blank piece of paper, draw the circle.
No.
Yeah, we are.
Yeah, they gave me last year.
Yeah, the same one from last year. There you go. All right, so let's keep on going. We got to do this quadrant, this quadrant, this quadrant. Now, it's going to get easy. Carlo. No, yeah. You're not going to draw these on triangles. I mean, you can if you want to. I think it's going to take way too long. Yeah, just draw the points.
Oh, okay.
The triangles are only drawn so you can remember them easily. So let's keep it going. Here's the next angle. All right, here's the key. 3 keys here, and it's going to make your life really easy. Shh. Too much discussion. Here it is. I already have 90 degrees. That was from here to here. If I add 30 more, this angle right here, here to here, is 120 degrees. I have 90 to go from here to here, and then I add 30 more. This is 120 degrees. Yes. 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 Yes.
We just need to find one.
Yes. 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 Question, Carl?
The circle radius.
Yeah. So 120 degrees. So let's label this point. Here's the genius of it, as Miguel is already seeing.
-1.
This point has the exact same y value as this point. So this is just √3/2. And the x value, well, I'm on the left side, must be negative. -1/2. That's all it is. That's all it is. So what's the next one? Well, the next one is, let's come over here. I'll do the radians here in a sec, but just let's go do this. This is 135 degrees. 135 degrees. So the y coordinate is the same. The x coordinate is negative. X coordinate negative, y coordinate the same. That's it. All you have to know is one quadrant, and then use logic. That's it. So what's the last one? Let's come over here. 150 degrees. This is equal to this. So what do we have? Well, the x coordinate is negative √3/2, and the y coordinate is 1/2. And then this is half of the circle, so 180 degrees. And of course, that's just pi radians. 150? Jake? You gotta know the angles, you gotta know the radians, you gotta know the points. Yeah, you gotta know those. Yeah, you gotta know those. Alright, now, what's a nice little memory trick that Kimberly Diaz taught me last year? She said, well, you guys know Kimberly Diaz? She graduated, I don't know, maybe you guys know. Okay, 120 degrees. She said that's just, so she said the answer is 2 pi over 3. And I was like, yes, that's right. And she's like, here's how I did it. I said, well, here's a 3. And the numerator of this is 1. So she said, I just did 3 minus 1 is 2 pi over 3. So she said for the next one, I'll do all 3, then you'll see it. So she said for the next one, she's like, the answer to this is going to be 3 pi over 4. And I was like, you're right. She said, I just said, here's a 4. There's an imaginary 1 up here. 4 minus 1 is 3. 3 pi over 4. And then she said, you know, this is going to be 5 pi over 6. And I was like, you're right. And she said, there's a 6 here and there's an imaginary 1. 6 minus 1 is 5 pi over 6. And then she said 180 degrees is pi, so she knew that already. Because that was the conversion factor. So that was how she got this quadrant super easily. No, you don't have to show work. Just draw the circle.
You just
Just
need
draw
to
the circle.
remember.
I'm about to Google
Just
it.
gotta memorize the circle. However you're gonna do it. Yeah, Mitzi.
Can we just staple them?
Yeah, we're about to do that. Yep. So quadrant 3 now. Here's the first one. 210 degrees. 210 degrees. And notice this has the exact same x-coordinate as this point. So x-coordinate is the same, negative root 3 over 2. What happens to y? It goes from positive 1/2.
To negative.
You guys can draw the rest on your own. You don't even need me. So the next one, 225. I'll do the radians at the end. So you should draw these on your own. There shouldn't be any challenge drawing these now. You don't need to wait for me.
Negatives and everything, the radians, what she said
Hmm?
about the.
I'll show you how. Give me 2 minutes. I'll show you that trick. 225. You say, well, let's look at this. Same x-coordinate, so negative root 2 over 2. Y-coordinate becomes negative root 2 over 2. Carla? And then the last one, 240, you say let's come down from here. Well, what is this going to be? Same x-coordinate, so negative 1/2. Y-coordinate becomes negative, so negative root 3 over 2. So now if we ask you what is the cosine of 225, you say, well, cosine is x, so negative root 2 over 2. That's it. That's it.
How are you adding the angles?
So 30, 15, 15, 30. 30, 15, 15, 30. 180 plus 30 is 210. Plus 15 is 225. Plus 15 is 240. Plus 30 is 270. 30, 15, 15, 30. And now the beautiful trick about the radians. So the trick for radians is all you do is you say, well, 6 plus 1, 7 pi over 6. Mm-hmm. 225, 4 plus 1 is 5 pi over 4. 240, 3 plus 1 is 4 pi over 3. 270, 2 plus 1, 3 pi over 2. That's all it is. You got to know one quadrant. Just know this quadrant. And how do you know this quadrant? Because you know this. It will become pure memory work. You'll know this like you know the alphabet. Not by Friday maybe, but the next couple weeks you will. We're going to do this for the next 3 months. You got to use this for 3 months. Get this in your head. Maybe tattoo it. Like this one? Yeah, start there. Yeah. Carla. Pi over 6, pi over 4, pi over 3, pi over 2. And now you guys can finish this off on your own. You don't need me, but basically it's going to be 300 degrees, 315, and 330. And then the radians, here we go. Six plus 7. How did it get 7? Oh, what am I doing? I'm here. 3 plus 2, 5 pi over 3. 4 plus 3, 7 pi over 4. 330. 6 plus 5, 11 pi over 6. 180 is pi, so that means 360 must be 2 pi. And you guys can fill these quadrants in. It's all online. Khan does a great job of it. I'll see you after school, guys. Good job. Thanks for suffering through. We're almost there.